Hi, this is Khatri. Thank you for attending this seminar. Our topic is landslide repair, structural retrofit of buildings for common interest developments. My company is Khatri International. We're based out of Las Vegas, Nevada, with offices in Southern California. So this slide just tells us the purpose of this presentation and how it satisfies the Department of Real Estate guidelines so that you can qualify for continuing education credit. This is the online version, so there's no continuing education credit available for the class online. So this is just for information only. I do teach it occasionally for local chapters, though, if you want to inquire with me. Our topic list is fairly extensive. I'll try to keep it as interesting as possible. We're going to go over hillside failures. We're going to look at a couple of cases in Rancho Palos Verdes, Malibu, hillside instability, the whole issue with insurance, which is a big problem in this area. And there's some timeline issues as to when the building was built, buildings built before 1971, the construction process, and then hillside considerations for structural foundations, and then solutions, deep piles, grade beams, slope stability issues, and issues with retaining walls, and what are the options to fix landslide damaged buildings. Well, so one key factor in when you do an evaluation like this is the date of construction. Buildings that were built before 1971 were done before the major grading ordinances were changed in Los Angeles. We're speaking specifically to Southern California. We didn't have requirements for soils reports. There was no requirements on deep foundations. It was pretty much what I would call the Wild West. And so buildings that are built before 1971 have greater potential for damage, for sliding, and changes in the water of the inside the slope over time. And so I would render those buildings as being far more riskier than buildings built after 1971, although all classes of buildings can be subject to failure, but buildings built before 1971 are subjected to a higher risk. There are different categories of landslides, as you can see here on this chart, and this all depends on the geography of where you are located. This is one of the first things that we look at when we come out to look at a property. I myself, being a structural engineer, will look at the building, but I will bring a geologist with me and or a soils engineer or both to look at what is the root cause of the problem. Are we dealing with an actual landslide, or are we dealing with a water loss situation? Is there drainage involved or lack of drainage? All of these factors circulate around one major root cause, which is water. And the root cause is very important to understand so that we can then come up with a repair. Unfortunately, most of these, if not all of them, are not covered by most insurance policies. It's possible you might get some coverage by linking them to a flood event or a rainstorm, maybe. That's more of a legal question. But this is an area which has been sort of abandoned by insurance quite a few decades ago. They used to provide coverage for this, but it has disappeared a long time ago. So this puts homeowners at greater risk for financial loss. There are many examples of what's been happening in Southern California. Orange County in particular has faced quite a few of these issues. You can see in the excerpt here from the Los Angeles Times. And proactive evaluation of your property to deal with the potential risk is the best, because you can retrofit these buildings in some cases to prevent it from happening. But if you've left your building alone and you're not paying attention to what's happening around the perimeter, you could end up in a situation like this. And of course, this has been a big issue in Rolling Hills Estates, where homes have been destroyed by landslides, and insurance coverage is not there for most of these. So determining the cause of loss is part of what I do, in addition to assessing the damage and coming up with a scope of repair and a cost to repair. And this has been a case that has been in the news quite a bit. The railroad line from Amtrak has been blocked several times by a landslide situation. So it affects not just the residences, but it also affects transportation. And this has been going on for decades. It's not a new thing, unfortunately. This was the La Conchita landslide, which they determined was due to a deep slide linked to slope stability issues and a lack of subdrains. The surface water flow was left uncontrolled, and the subdivision down below was destroyed because of this. So what are some of the typical issues that we found in our years of investigation on this topic? Well, we found in many cases that the site conditions did not match what the design engineers had expected. That would be a grading issue or a drainage issue. We found ruptured water lines that were leaking, construction mistakes, lack of compaction leading back to the design plans not being clear, many cases of buildings being built without proper permits, construction citations that were not corrected, and in general, working conditions that did not match the original scope of the work, construction and engineer errors, and in some cases, conflict of interest, where inspectors didn't really do their job properly for whatever reasons. So even though this would be considered preventable, which I think all of these are preventable, they do happen, and they happen today as well as they were happening 20, 30, 40, 50 years ago. And it's unfortunate, but this is part of the process in the root cause analysis, is to determine what went wrong before we can come up with a solution. So one of the things that we first try to determine is that are we dealing with a slide or are we dealing with settlement? Is it sinking? And so we look at the warning signs. There are ways to determine this. We have instruments that will come out to measure the building. We will look at the water bill to see if the water lines are leaking. Are the pools leaking? Do we have cracks in the slope? Were there previous construction citations? We'll look at the permit records. Is the concrete cracking in a particular pattern? Do we have wall frame cracks, door cracks, window cracks, which would indicate that the structure is sliding? And we'll do a floor level survey. So these are all tools that we apply as engineers to determine the root cause and whether or not we're dealing with sliding or sinking or both. And that's very important because that tells us what has gone wrong so that then we can deal with it in the fix. This is kind of a comprehensive flow chart of what we do as structural engineers. We first identify the issues. We do a root cause analysis to determine the causation and then identify a fix. And then we'll come up with a design solution and help the owner to come up with a budget. And once that step 1, 2, and 3 are done, if the owner is able to proceed, we'll then, with their authorization, go through the permit process. We can also help the owner with construction management to manage the reconstruction, manage the repair. So we will seek bids from qualified contractors, get the permits approved, finalize the budget, help the owner to select a general contractor, and then finalize all the details, the schedule, the budget, payment plan, and get into the construction. It's a fairly lengthy process. In Los Angeles, Orange County, this process could easily take more than a year. Just the root cause analysis, depending on how complicated the problem is, how complicated the site is, could take anywhere from 6 months to 8 months just to get all the data. So this is definitely not a 4-week turnaround. This is fairly lengthy and obviously can be quite expensive depending on the size of the building and the scope of damage. So having been doing this for almost, more than 4 decades, I kind of made a list here of some of the main issues that I have found in Southern California dealing with buildings, which drainage would probably be my number one, where we have lots of issues in Southern California with improper drainage. This causes not just landslide issues, but flooding and water infiltration into the building. We do have many areas of Southern California that have expansive soil. Expansive soils in Malibu are quite common, and in Orange County and certain areas of the coastline. An expansive soil is a soil that will grow in volume when exposed to water and then contract as the volume dissipates, the water dissipates. Many buildings built without proper steel, I've seen that so many times. And even though we have the best weather in the world, I think, thermal cycles in California can be quite drastic, and that will cause concrete to crack. We have a fairly dry, wet climate cycle, and lots of issues dealing with block walls, retaining walls, and of course stucco. Stucco is cracking all the time. Just a broad brush list of issues that we run into in Southern California. So just to give you an understanding of what we do as engineers and construction managers, is we are experts hired to help you, property managers and HOA board members and property owners, to evaluate the problem and come up with a solution. Property managers are not construction managers. They're not, they may be knowledgeable, don't get me wrong on this, but they're not the construction experts. And so we advise that you should always seek expertise with the correct professionals. And I wanted to explain who these professionals are and what we do. So there is the structural engineer, which has the title of SE. That's a specialty license for structural engineers that comes after they get their PE. An architect is totally different license, but an SE is a specialized license. It's kind of the same thing as when you go to see a doctor. You have a general practitioner, and then you have specialists. Well, a PE is more of a general practice license, and an SE is a specialty license, just to deal with structures. The same thing applies to geotechnical engineering. That's a specialty license that you earn after your PE. And the qualifications are quite steep. I mean, an SE license requires at least, I have never met an SE with at least 10 years of experience. Usually they have 15 to 20 years of experience, and the GE is the same, the geotechnical engineer. Then there is the engineering geologist, who's an expert in geology, slope analysis, and the macro slope analysis. And contractors who are very knowledgeable, certainly very knowledgeable in construction, but remember that they're not technical experts. And they may offer you design solutions, maybe good design solutions, but they don't have the expertise to draw a set of drawings. So just be wary that they're experts in their field, which is construction. And I'm also a licensed general contractor, so I respect what the contractors do, but let's not confuse what the other professionals do who are trained in a specific area. So you need all of us. You need a structural engineer, a geotech, a geologist, and a contractor to deal with the technical ramifications of this. This slide is taken from the FEMA website, and it is the National Risk Index for Southern California. And what's interesting here is that this is generated by FEMA, which accounts for all relative risks across all the counties in the United States and ranks them considering all of the vulnerabilities, which includes earthquake, flood, hurricane, tornado. And you can see here that Los Angeles, Orange County, Riverside, San Diego, and San Bernardino County have the highest risk rating in the country followed closely by Santa Barbara, Ventura, and Kern, and Imperial Valley, mainly because of earthquakes. And so Southern California is highly prone for potential risk, damage to earthquake, landslides, uh, and of course, even tsunami along the coastline. So this is done independently by a government agency, and I wanted to share it with you to explain the situation that people in Southern California are living with, not just the risk exposure, but also the lack of affordable insurance, which makes California, Southern California in particular, highly susceptible to a potential economic loss with a huge financial risk, of course. And this slide is generated by the California Division of Mines and Geologies in conjunction with the City of LA and various agencies. This is the seismic hazard map of Los Angeles County, which marks the major fault zones, and also the green are landslide zones and liquefaction zones. The green are liquefaction zones, and the blue are landslide zones. So a lot of major faults and a lot of seismic hazard, obviously, in Southern California. You can see from the map the liquefaction potential is quite substantial. And to understand what liquefaction is, when you have a stable soil on the left side of the figure, in the event of an earthquake, that soil will not collapse. In a liquefied soil, during and after the earthquake, literally the soil will turn into basically like mud or quicksand, and the buildings will sink or they'll displace unevenly. And that's why it's called liquefaction, because the soil basically liquefies and everything on top of it sinks. It's a very dangerous condition, and it is quite prevalent in Southern California and in Orange County. This slide is the liquefaction zones for Orange County, which in the blue there show you quite a bit of Orange County is subjected to liquefaction. This magnifies the earthquake risk factor because, again, as the previous slide showed you, the risk potential to buildings is very high, and you can see the blue zone covers quite a bit of Orange County. And this slide shows the flood zones for Orange County, which you can see almost overlap with the liquefaction zone and the seismic zones. So Orange County, Los Angeles County, with all of these factors considered, are very high risk zones, and FEMA has recognized that. And insurance has recognized this. And that's one of the reasons it costs so much to live in California, because insurance costs have to deal with all of these high risk factors. Certainly a beautiful place to live, no doubt. No one is doubting that for a moment. But the risk factors also have to be considered. And in every analysis, when we look at a property, particularly on a hillside condition, which is very prevalent in most of Southern California, there are a lot of hillsides, particularly when you come to the coastline and you have bluffs, we have to consider this global condition called slope stability. And slope stability is a specialized analysis done by the geologist or the geotechnical engineer using a mathematical equation to determine how stable a slope is. They take the parameters of the slope, put it into a computer program, a model, and they determine if the stability factor is safe. And it's produced in the form of a factor of safety. The factor of safety is the ratio of the slide potential to the safety potential, or safety capacity. And that ratio has to be greater than 1. If it's less than 1, that means the slope is highly unstable and it'll fail. Normally, they look for a safety factor of 1.5, which means that they want to have at least a 50% margin that the slope has capacity to not fail. It used to be a safety factor of 2. They've lowered it in the last 20 years. I remember 40 years ago it used to be 2, but now it's 1.5. So this is one of the parameters when we look at properties, we do look at slope stability. It's a critical element. And this slide we saw a little earlier gives you the different types of failures that can occur. Rotational landslides, block slides, debris avalanche, and creep are very common. The other ones also occur all throughout Southern California. PCH is very much susceptible to rockfall landslide. You can see there under Category D and Category E. And then after fires, when heavy rains come, Category F, the debris flow, is a big problem in Malibu. Big problem in many areas of the Los Angeles County mountains, and also in Orange County. So these categories are evaluated on a case-by-case basis, and we look at them to see what type of landslide we're dealing with, so that then we can come up with a solution. And in some cases, there may not be a direct solution. It may be that that property is not buildable. This is very possible. It depends on the category and the cause. Not every piece of land can be built on. Some properties were built on some of these landslide zones many, many years ago, and no evaluations were done. No geotechnical or geologic investigations were done. Some of those properties will have to be abandoned. This is just the cold reality of the situation, because we can't change Mother Nature. So one factor that we look at quite importantly, which is done by the geologists, are the bedding planes. And if you think of bedding planes, think of a deck of cards. If you have a deck of cards and you tilt it slightly, the cards will slide because they don't have sufficient friction between the cards to keep them in place. Those are bedding planes. And so if you have bedding planes that are oriented in an unfavorable direction, such as what we're showing in this diagram, where the bedding planes are angled with a dip angle downward, and the dip direction, as it shows in the diagram, are unfavorably angled downward so that gravity will drag them down, there is a higher propensity for those bedding planes to slide. So this is something that geologists look at, very important parameter, because if you have unfavorable bedding planes and the dip angle is unfavorable, you can't build on that property. Because no matter what you do, put in a massive retaining wall, put in piles going down 40 feet, the bedding planes are going to carry that building regardless. So you have to pay attention to these things. These are the unfortunate realities of Mother Nature that we cannot change. And this slide is rather relevant, especially today, given all the issues that are happening in Rancho Palos Verdes, in Rolling Hills Estates. We have a number of issues going on in this area of Rancho PV. So I have marked out here, or the map data shows here from Google, the liquefaction zones, which are in blue. You can see them over on the right-hand side, and you can see the numerous landslide zones, which are in purple. And remember, this is a global map. You have to look at every property individually, and you have to look at, from a specific, site-specific analysis, whether or not your property is in a landslide zone. You can see the earthquake faults are running right through Rolling Hills and right through Rolling Hills PV. And the orange dots say that they're near a hazard. So Rancho PV, Rolling Hills Estates are in a very high-risk zone. There are a lot of issues in that area, and most of those buildings were built decades ago. And so it's no surprise to an engineer, at least to me, that they're having all these issues, because they're in a zone which has lots of complications, lots of problems, and they haven't really paid attention to it. And unfortunately, the attitude amongst many property owners is they don't worry about it until it actually becomes a problem. And that's just not the right attitude. You have to start looking at it now, as we've learned already with other failures around the country. So here we're just trying to meet the requirements of the Department of Real Estate, explaining why it's important for property managers to consider these issues and to consult with experts So this slide is for the folks who are looking for their continuing education. This is a YouTube presentation, so it does not apply, but I am a certified instructor, so I have this in the content. And so this is the process that we follow in my company in the reconstruction process. The first thing we do, we have 3 phases. We have phase A, where we evaluate the claim, prepare the preliminary plans with specifications, and come up with a cost estimate. If there's insurance coverage, great. If there isn't insurance coverage, well, then we have to deal with it. But in phase A, we're trying to assess the causation of the problem, scope of the distress, and how we are going to fix it. Phase A is very important. We can't do the other 2 phases without starting with phase A. Then phase B, we will execute on the recommendations of phase A to come up with a reconstruction plan, which will be for construction and to pull permits through the local building department. Permits are very important. There are a lot of associations, property owners who try to do things without permits, and I can tell you, you're just asking for trouble. Because without permits, you don't know what you're buying, you don't know what you're doing, and you will affect your insurance coverage in a negative way, to the point where insurance carriers may drop you if they find that you're doing work illegally. Phase B is mandatory. You've got to do everything with permits and with documentation, and for that you need a professional engineer or a licensed architect or both. Phase C is the execution to actually go build it. And that, of course, you need a professional licensed general contractor with all the relevant insurance. I've always advised my clients to consider a construction manager, a professional that is an expert in this area who can guide you and keep your project on track. But don't skip any of these steps. I've seen many customers who skip directly to phase C and they just end up with a mess. They end up having to do everything over again. So I urge you to look at all 3 steps and do them methodically. So as I alluded to in the previous slide, that doing work without permits could lead to an uninsurable situation. Plus, you don't know what you're paying for. You don't know what your contractor is really doing for you. And if you don't have a legal construction contract, you are exposed for potential workers' comp claims from the state of California. You don't know if your workers on the site are insured by the construction company, and you don't have any professional oversight. You don't have any specifications. You have no drawings. So it's just a bad plan of action. And unfortunately, I see many customers doing this 1, 2, maybe 3 rounds, and it's a mistake. So we try to help our clients to find coverage. That doesn't mean that they're going to find it. We will help property owners to bring in an insurance adjuster or an appropriate legal counsel if it's necessary. It's always good to find coverage, but if the coverage is not there, it's not there. And this boils down to evaluating the cause of loss and identifying if that cause of loss is covered. Unfortunately, a lot of claims go without coverage because there was no technical investigation. So I urge you to do the process correctly, do the phase A, do a technical analysis, and see if there is anything potentially covered. And get qualified professionals, if necessary, a private insurance adjuster to investigate their claims and exhaust all options under your insurance policy. So what kind of repair solutions can we offer? Well, the traditional solution is what we call deep foundations, which are to put in a pile cap with deep piles. And this is expensive, no doubt. It's more expensive to install it after the fact than to do it the first time around. But many properties that were built back in the 50s and the 40s may not have this, likely will not have it. So we're able to put these in after the fact and not necessarily restore the building, but at least stabilize the building to keep it from sliding or sinking or whatever the solution, whatever the cause may be. But this is the deep foundation or pile foundation design. So a couple of common errors that I've seen with many homeowner associations, property owners in general, is not recognizing the urgency of the repair, ignoring it, letting it, or so as we say, kicking the can down the road, not getting the appropriate experts, relying on third-party vendors who are not necessarily qualified, and not making a resolute and decisive decision to move forward. Sometimes you have to make an assessment. Sometimes you have to, increase dues. You've got to do it. I mean, if you don't do it, the cost on the other end is much higher. And take care of your vendors. Make sure you don't lose the interest of your vendors, your professionals, the engineers, the architects, the contractors, because you need them to help you resolve these issues. So to summarize, Southern California is one of the most beautiful areas in the world. There's no question. The view, the weather, the ocean, the mountains, no one's going to dispute that. I'm a big fan of Southern California. It has its risks. It has the liquefaction and landslide zones. It's a heavy high-risk earthquake zone. It has a flood zone. It has a high wind zone. And it's an arid and dry climate with large temperature variation. All of these things make longevity of property challenging. Not to say that other parts of the country don't have their own problems. Every part of the country has a problem. But you've got to recognize that in paradise, you've got to pay the cost of living in paradise, and it's not cheap. So my conclusions from today, I hope you got something out of this presentation. We've evaluated landslide potential. We've discussed foundation damage, insurance coverage versus no coverage, how to do a technical evaluation, at least from a broad brush standpoint. We discussed one repair method. There are many other repair methods also, which I can share with you on a site-specific basis. The importance of getting permits, plans, specifications, and quality control on your project. Realizing that insurance adjusters are an important aspect to help you in evaluating your insurance claim. And fiscal management of your funds and making sure that you stick to the plan and you execute on the plan. Very important, and don't ignore or let the problem persist. Deal with it. So I do thank you for your attention here on YouTube. Give us a like, give us a subscribe, let us know how we're doing. I put this content up to help you and certainly appreciate your feedback. You're welcome to share in the comments below. And if you would like to contact me, send me a comment or an email. My email address was on the first slide. And thank you very much.